Hey everyone, welcome back to my lesson. I'm so glad that you're here, whether you're a long time supporter or a brand new to the crew. Thank you for tuning in. We've got something special lined up today. So sit back, relax, and let's dive in. Don't forget to like, comment, and subscribe if you're enjoying the video. So today, guys, we basically focusing on area rule, focusing on area rule. After area rule, we'll go to sine rule and then cosine rule, right? So now today we only focusing on area rule. Um, Now before we dive deeper, let's start on trig ratios. Let's say for an example, they give you something like this. Let's say for an example, they give you a triangle, right? And then maybe this is 2, this is your C, this is B, and then angle 30. So because of this sign, which means this is a right angle triangle, and then maybe the question comes and say, look for the side B, and then maybe as well as the side C. So now you ask yourself the first question to say, is this triangle a right angle triangle or not? If it's a right angle triangle, we use Pythagoras theorem or we use the trig ratios. Okay? But whatever the information given to you, if it accommodates the Pythagoras theorem, then you can dive to Pythagoras theorem. But if it doesn't accommodate, then you move to trig ratios. So for this question, I don't think information given to us will accommodate the Pythagoras theorem. So we move to trig ratios. For trig ratios, you have your sine theta, your cos theta, and your tan theta, right? So for sine, we have our opposite over hypotenuse. And then for cos, you have your adjacent over hypotenuse. And then for tan, you have your opposite over adjacent, right? Um, some they prefer to use they prefer to use y over r, x over r, and y over x. Still okay, still right, ne? So for trig ratios, we have sine theta, which is equal to opposite, blah blah blah, right? So now how can we get b? For an example, that's the first question. How can we get B? And we are given 2. First thing first, we analyze the sketch. So we have the angle. Angle is opposite to this side, which makes this side to be our opposite side, right? And we're looking for B. So B is our longest side, which means it's the what? The hypotenuse. So we need to look for the trig ratio, which has opposite and hypotenuse. That's the sign. So obviously, we'll say sine theta is equals to opposite. Okay, let's just say this is A, B, and C, for an example, right? So sine theta is equals to opposite, that's AB, over hypotenuse, that's AC, which is equals to sine 30 degrees, equivalent to 2, that's our opposite, hypotenuse, that's B, right? And then from here, at this stage, that's when now you can start applying your mathematical gymnastics, right? That's when now you can apply your mathematical gymnastics. So, um, this is a situation whereby now they gave you uh, a right angle triangle looking for a side, right? We apply or we use Pythagoras theorem or the trig ratios. So now, what happens if now maybe they are looking for a side, but then the triangle is not a right angle triangle? Maybe they give you this kind of a triangle where this is A, B, C. What happens? Maybe if now they are looking for a certain side now, they're looking for a certain side. Let's say now they're looking for a certain side, but then they give you a triangle which is not a right angle triangle. That's when we start using the sine rule. We use the sine rule or cosine cosine rule. And then if maybe you're also looking for the area whereby you don't have a perpendicular height as well, we also use the area rule. You use the area rule. So now, with that being said, we can conclude and say the area rule is used to determine the area of triangles which are not right angle triangles, or triangles where the perpendicular height is not known. That's our conclusion based on the area rule. So for now, we will just focus on the area rule, even if we have three of these rules. So, but we'll focus on this one, the area rule, for today. So now, let's say now, okay, before we even continue, I want us to, I want to actually write the area rule for you. So let's say now we're given a triangle. Let's say given a triangle where this is A, this is B, and this is C, right? And then uh, we are given an included angle, which is A, right? Why do I call this an included angle? The side opposite to that angle is A. The side opposite to C is small c, and then that one will be our small b. So we call this included angle because now we have two sides surrounding the angle, right? Or you have an angle between two sides called A or labeled A and B. So hence we are saying A is our included angle, right? Um, Now we're looking for the area of this triangle, given that A is an included angle. So we have to say the area of triangle ABC, that's equals to, okay, by definition, we know that the area of a triangle is equals to half base times perpendicular height, right? So we apply the same logic even here, but it's a bit different. But I'll explain everything as time goes by. So with that being said, now we can also say the area is half and then side 1 and side 2, B times C. So those are two sides which created an included angle A, right? Two sides which are surrounding an included angle A. So we say half times BC, multiplying those two sides, and then now we say sine A, considering the included angle. That's the first situation, right? Second one, a situation whereby now the included angle now is our B. Again, we call this an included angle because obviously now we have that angle B between C and A. So now, obviously, I believe that everyone now, they understand how to write the area of this triangle ABC. So you'll have your 1 over 2, and then side 1 and side 2. But let's use the alphabetical order. So that's AC sine, what is our included angle? That's B. Sine B. So we include B. Same applies to when we are given um, your A there, B, C, that's an included angle, which is our C there. And then now C is our included angle between B and A, right? So the area of triangle ABC would be 1 over 2, and then two sides you have A and B, and then sine, sorry, and then sine C. So that's the area rule, right? That's the area rule. But before we even start with the area rule, before we use the area rule, I want us to derive. I want us to derive the area rule before we even use the area rule. Let's derive the area rule now. So let's say now we are given an acute angle, right? Let's say we are given an acute angle of this kind, right? An acute angle triangle rather. Let's say we're given an acute angle triangle where this is your A, this is your B, and C, right? And then they also give you the perpendicular height. The perpendicular height, and then they label this as our D, and then you also have the distance from A to C. Let's label the distance as our small b because obviously is opposite to angle B. And then side opposite to angle C, that's small c, and then small a because it's opposite to angle A. And then let's also label this angle as our included angle. Perfect. Now we're trying to prove the area rule. But we all know that the formula of the area of a triangle, area of triangle ABC, given as half base times perpendicular height, right? As I've explained earlier. So this would be your equation 1, right? And then let's focus on triangle ABD. So with that being said, I will just specify the triangle that I'm working with. So I have A, B, D, right? So in triangle ABD, I want to look for sine A. I'm looking for sine A. So let's look for sine A using the trig ratios. So you go back, okay, this is our perpendicular height. So when we go back and look for sine A on this triangle, that's our triangle ABD, right? how do we get our sine A there? So the angle opposite to H, right? So that angle makes this H to be our opposite, right? And then this is the longest side and also the side opposite to our 90-degree angle becomes our hypotenuse, right? So your H, that's your opposite, and then you see that's your hypotenuse, right? So remember now, sine A or sine theta rather, is equals to opposite over hypotenuse. So same applies to sine A would be opposite over hypotenuse. But now, what is our opposite? Our opposite is H, and then our hypotenuse there is C, right? And then from here, we can just use the mathematical gymnastics, use multiply both sides by C. So when you multiply both sides by C, you'll be left with H over C times C, right? And then C and C will cancel at this stage. And you'll be left with something like this, right? So let's label this as our equation 2, right? And then from our equation 2, now we can say substitute. Now, substitute equation 2 into equation 1. Okay, here's our equation 1. So for equation 1, you have your what? Area of triangle ABC being equals to 1 over 2 base times height. But then now our height h equals to c sine A. So we can say 1 over 2 times b times our c sine A. So now we've derived the formula for the area. We've derived the formula for the area. Remember what did I said? Remember what did I say? I said um, if A is our included angle, then you need to have your A there, right? And then the two remaining sides, which makes A an included angle. In this situation, C and B makes A to be an included side. Hence, now we're having half B times C sine A, right? So we can also say similarly, the area of triangle ABC can also be written as half AC sine B if our B is what? An included angle. And then if our C is an included angle, again, you will have your half base times AB and then sine C, because now C is our included angle. I believe that everyone understood that part, right? I believe that everyone understood that part. So guys, if it happens that you did not understand whatever that I was saying, you can pause the video, go back and try to understand everything. You're more than welcome to do that. You're more than welcome to do that. So now let's continue. Let's continue. Now that we've proven the area rule, now we need to apply the area rule. We need to use it to answer the questions. So now for example one, on our example one, we must look for the area. Determine the area of the triangles. Of the triangles below. and then they give you triangle number 1, where the 6 there, 8, A, D, okay. First thing first, you need to ask yourself a question. Is this a right angle triangle? No. Um, do we know our perpendicular height? No, we don't know the perpendicular height. Perfect, which means now the story of uh, um, trig ratios or Pythagoras theorem, it's not working here. This is not the right angle triangle. So what do we use? We use the error rule. Now, we have conditions of the error rule. How do we use the error rule? We can only use the error rule if we have an included angle. That's when now you can use the error rule. So now, do we have an included angle here? Yes, we do have an included angle because these two sides, they make this angle to be an included angle. So that's why I'm saying we have an included angle. Perfect. So you have your area of triangle ABC. ABC is equals to half um let's say AB. AB times AC sine included angle, that's A. Now let's try and analyze this thing together. AB, this is the side AB, which is 6. And then AC, this is the side AC, which is 8. And then sine A is this included angle. I hope it makes sense to everyone. So now let's now try and substitute now. Plug in the information. So your AB, that's 6, and then your AC, that's 8, and then sine into that angle, that's 30 degrees. And then you get your 12 units squared because this is what? An area. That's the first example. Let's move to the example. Example number 2. So for example number 2, now, now they're trying to change the situation. Now they're trying to confuse us. Now they give us something like this. You have 21 centimeters there. We have 25 centimeters. We have your okay, sorry. You have your 20 degrees, your 23 degrees, and then there's an unknown angle there, right? So we're looking for the area of this triangle. Again, you have to ask yourself certain questions to say, okay, is this a right angle triangle? It's not a right angle triangle, which means we need to use the error rule. But then now, if we use the error rule, we need to follow certain condition, which is our condition number 1. Do we have an included angle? No, we don't have an included angle, right? Our included angle is an unknown. Okay, that's okay. That's not a problem. So the only thing that you can do at this stage is the fact that you need to look for your included angle. So that's A, C, and B, right? Now, how do you find your included angle? That one is not difficult because we did Euclidean geometry, right? So we use sum of angles in a triangle, meaning now we can say angle A is equals to 180 minus 20 degrees plus 23 degrees, right? Which will give us 137. So when you add all these three angles, you get 108. That's what it means, basically. And then after getting 137, now we know that this angle is equivalent to 137. So now, which means you have your included angle and two sides, right? So now we can start answering the question. Now we can say the area is equals to half. Now, first side, that's 25. The second one, you have 21. And then sine, what is our included angle? 137. 137 degrees. And then equals to, your area would be 179, 0 centimeters squared. So here, guys, do not stress. I'm just rounding off to one decimal place. But remember, during an exam, they will instruct you. They will definitely instruct you during an exam. And then again, okay, I'll just add one more example. One more interesting example. And then I'm done. But I'm so happy that you've pushed till this stage of my video. I'm so happy for that. Now, example three, number 3. Now they're giving us this type of a triangle. Where this one, it's 140 degrees. Okay, then we use a different color. I feel like people, they tend to understand when there's different colors. And then here we have your 30 millimeters. We have your 19 millimeters. This is your B, C, and A. And then here they gave us 78 degrees. Yeah. So again, we're looking for an area of this triangle. Now the condition, do we have an included angle? No. Our included angle is an unknown, which is C. How do we get that included angle? Again, we can use the exterior angle. The exterior angle says exterior angle is equals to the interior opposite angles is equals to the sum of the interior opposite angles. Hence, I've decided to do this, to say the exterior angle is equals to the sum of the opposite interior angles, right? So what do I mean by that? I'm simply saying angle A is equal to angle B plus angle C, right? Now, what is our angle B? Angle B, that's 78 degrees. Angle C, unknown. Angle A, that's 140, right? And then from here, actually now we can start transposing 78, meaning now you move this 78 to the other side. So obviously now, if you move that number, it changes the sign from positive to negative. And then 140 minus 78, you will get your 62 degrees, right? So you see that's 62 degrees, meaning now you have your 62 degrees there. And which means now you have your included angle, right? We have the included angle. We're looking for this situation all the time. We're looking for this situation whereby we know that angle. These two sides, they make this angle an included angle. That's when now we can find the area, right? Using the area rule. So now what is the area of this triangle? Again, we can say A is equals to 1 over 2. Now, you have side 30 there, which is a side AC, which is 30 millimeters. Sorry, that's so messy. My 30 is so messy. And then side BC, which is 19, right? Sine our included angle, that's sine C, right? Our included angle, that's C, rather. So angle C, that's 62 degrees. Perfect. And then now, you just use your calculator here, and then you get you 251.6, 1 decimal place, millimeter squared, right? So obviously I'm using a square because this is an area. So guys, this is it for area rule. I believe that everyone understood everything. And I'm so glad that you guys you've watched my video to this stage. Thank you so much for tuning in and enjoy your day. Bye.